This is Don Larson again. We are ready to get started. But before we get into our actual presentation, just let me kind of go through the our webinar housekeeping rules again. If you should experience any problems during the webinar, use the little questions window. All attendees will be muted for the duration of the webinar. There are some associated materials with this webinar that is in the control panel. You can just, under the handout section, you can drag and drop those documents to your desktop, and we will invite you to do that. Post your questions during any time. We'll answer questions at the end, but go ahead and post your questions as you think of them while they're fresh on your mind. So we invite you to do that too, and then it also gives me a chance to kind of ponder them a little bit before the Q&A session. And then for those of you who are not familiar with Larson Software Technology, we're based in Houston, Texas. We were founded in 1984 as graphics technology experts, and we've been doing that for over 30 years. In the beginning, we started by promoting the CGM standard when it was first introduced with a free CGM viewer. We're a member of the CGM Open Foundation that maintains the CGM standard, and was also worked with S1000D and when it was getting started on the graphic standard on developing the CGM profile for S1000D. Our product is, we develop powerful 2D and 3D technical illustration software, and along with conversion and viewing solutions based on open formats like CGM and SVG. We were a developer of the first HTML5 CGM viewer that eliminated the needs for plugins, and we also introduced the first CGM profile to help to assist with the standardization of the file format for the aerospace industry. And we also currently participate in the S1000D graphics and multimedia working group. So that said, we'll now turn it over to David Manick for the main part of our webinar presentation. And I will be joining you at the end for the Q&A.
Thank you, Don. Good day, everybody. Thanks for joining us today. Yeah, I think one thing that Don mentioned there was we started with SVG with our own profile. I think I think Don might have misspoke when he said CGM, but it was actually SVG. We created a profile really to try and help with the standardization effort, which really leads us into the specification itself, S1000D. I think probably most people on the call today will be familiar with the standard. It was actually introduced back in the 1980s. And the concept was that it would be modular, which would hopefully then help when revisions take place, that these will be a lot easier to do because they just have to update one data module as opposed to the whole manual if it was linear. So that was the objective, a more flexible method of managing and publishing technical documentation. And I'll say today S1000D is widely adopted, and even more programs come online as we go forward. So certainly the forums are getting better, better attended, and obviously after the pandemic as well, that was always a challenge. So one of the critical parts of the S1000D spec is obviously graphics and multimedia, and that's the area we focus on. If you're interested in the spec itself, you can download it. There's no charge from the s1000d.org website. So you can just go there and you can download it. You don't even have to register. You can download it as a guest as well. And just to preempt, next year, the S1000D User Forum 2025 will be in Montreal, Canada. So perhaps you might want to mark that into your calendars. So as part of the the management of the spec, there is a particular working group, the Graphics and Multimedia Working Group, that was reformed in 2022. So it's been pretty stagnant until then, but since then it's been working hard on the first real kind of effort was on SVG to get that into the specification. That started 2 years ago, and it really just within the last few months has been with the issue 6 spec has now been introduced. So that's good news for people who want to use SVG. It's now officially part of the specification. We actually made some participated in that, mainly in an observational role. The next task of the group, which is already started, is the review of the current 3D graphic guidelines. So that has started, and I cannot say when these new guidelines might be out or some new information on that will be published, but certainly it's being worked on. And there's a possibility as well that there could be a 3D file format associated with that, but that's not certain at the moment. So the spec today, as I said, is issue 6. Obviously, other versions of the spec are being used by programs at the moment, but issue 6 is the latest iteration of the specification. There's been a few changes on the illustration side. Nothing really changed to the 2D guidelines, which we'll look at today, the illustration rules part. The 2D file formats has changed because of the fact that now SVG is part of the spec. So you could see that it's now part of chapter 7.32 and it's paragraph 2.5, and it talks about the S1000D SVG profile, which we'll have a look at today. The 3D guidelines, again, haven't really changed, and I said they're being looked at the moment, and there's no real specified 3D file format for delivery. There is one talked about data exchange, but nothing really on publishing 3D files. So here we have kind of a flow diagram. I'm just going to try and bring up a highlighter here. Oh, not highlighter, let's try something else. So hopefully you can see that. So we have a kind of flow here where a lot of illustrations today will come from 3D CAD data. Now they could, if they're going to be used as 3D in the actual item, they could just go straight down this line really and be used straight away into our CSDB. More commonly, they might be going to some kind of authoring type environment where they could be 3D to 2D. So we might create a 2D illustration in a CGM and SVG format from the 3D, adding interactivity and annotations. Alternatively, they could also be authored in 3D, also add in, say animation and things like that, and finish up in this part here in 3D, the 3D area. So, but both of these kind of legs will finish up in the CSDB. So this is where we're going to manage these illustrations in the common source database. Every kind of multimedia item that includes video and image data, but also illustrations, will have an ICN identifier associated with that. So each illustration or multimedia asset will have its own unique ICN number. We then go into the IETM, and we then need a way of viewing, that's your interactive manual. We'll then need a way of viewing that information within the IETM. So you're going to need, if you've got 3D data, you're going to need a 3D viewer of some ilk, also, or a 2D viewer. So these are kind of the prerequisites if you're going to deliver the S1000D data. Just going back here, we could also have legacy illustrations as well that have been created previously that could be revised and then still go down into this route, or they could come back in this direction and be revised and then back uploaded to the CSDB. Okay. So illustration guidelines. So I said these really haven't changed. But this is the chapter that they're in. If you want to download the spec, it's in 3921, and really gives you guidelines on how you should, or what your illustration should be looking like. Some of this is quite really common sense, that this should really communicate in a simple and clear and economical way, visually enhance, be aligned to the text. So pretty much what you're doing at the moment. So these are like kind of high level guidelines. And then we get a bit further down in that actually what should the illustration look like. And I think most commonly the projection that most of you are probably using is isometric, especially for spare parts illustrations, and really try and use consistent line weights and line styles for the illustration itself, and for the annotations and symbols should be consistent. You could also have the option to use color, although in saying that, most illustrations are probably monochrome for cost purposes, but certainly color is used, especially in the commercial airlines where they use color a lot. There is in the spec what they call a business rules decision point, where you choose to use color or not, depending on your project. We'll look at color again in a few minutes. So symbols, oops, let's just go back. So symbol of a thing that you could use, and there's a guideline for what the symbols might look like within S1000D. And also going back to color, there's a guidelines on the use of color. So we can see on here that yellow is attached to the main assembly. So we can see in the exploded view here, all the yellow parts are actually part of the main assembly here. The light blue are actual parts. You can see they have annotations associated with them. So this would be a parts list. And then gray items would be parts in subsequent illustrations. So they will have a part number, but not on this particular illustration. So there's some really good examples within the guidelines on how to use the color. There is a specific color palette as well for the specification, which you should use. I think this is quite important that you adhere to this, mainly because these have been researched and so forth for the best colors on an illustration in IATM. So that color palette is in the spec. What we created is an S1000D guide illustration, and I'm going to open that up and do the first demo. So we have a few live demos today of the software, and in this case it's going to be VisX Edit. So I'm just going to open up here, and this is the illustration. We just created this, and you can download it from our website. So you can see here's the color palette, and we've replicated that in the fill menu here. So you can see all the colors associated with the spec. You can see this an isometric illustration. There's actually a suggested reproduction area that you should use. One of the key things here is the ICN number. So you can see how this is broken down, and it would usually be positioned down here in the bottom right. So the ICN is the prefix, and then the cage code is usually the supplier of the illustration. So it could be yourselves, or it could be a third party. And then it has a unique identifier as kind of associated with the data module. So it's always unique for that particular project, and then an issue number and a security classification. So it's not something you would create usually if you were the author of the information. It's something that will be given to you by the project itself, but it usually would reside down here in the bottom right. You can see here we've also we created a small library. You can obviously add to that, so you can drag and drop these symbols onto the illustration, resize them, and so forth. But you could create your own library, or you could add these to this particular library here. as well. And it could be parts as well as symbols. And then finally, in Viz Edit, we have this way of saving as a template. So once you've set something up like this, you could save it as a template, and then other users could actually, other illustrators or authors could use this as a way of keeping everything consistent. So let's just go back to the slides. And next we're going to move on to the file formats themselves. And as I said earlier, SVG has now been added to the specification. So chapter 7.32 chapter 7.3 oops. I'm hoping you can still hear me. Don, can you still hear me? Okay. Okay.
Yeah, Dave. Yes, Dave, I can hear you.
Yeah, sorry. We had a bit of an interruption. Sorry about that, everybody. Okay. So we can see down the bottom here that SVG was added to the chapter. So as I said earlier, it was 2.5. So the S1000D SVG profile is now in issue 6 of the specification. So you would have to download that new version. But CGM is still relevant, obviously. I know some of you probably would now move away from CGM, but also there's companies with a lot of CGMs that the task would be very hard to actually migrate. So CGM is still really important, and we're still supporting it. There's 4 versions of CGM, but only version 4 can contain hotspot information, so that's the one being widely used today. The reason CGM was used because it can contain raster and vector data, and there is obviously a profile in the specification for CGM, so it's still obviously valid within the spec. So as I mentioned, CGM version 4 can contain what we call application structures, which can contain that metadata for hotspots. So we can add hotspot information to a CGM graphic. You can also have what we call an XML companion file. So there's only limited information you can put into the CGM itself, but with the XML companion file, you could add other data, say multiple screen tips that could be called out. I'll give you a short demo of that later on. And also, the spec provides you guidance on what that metadata can be. So it's still really, really relevant CGM. But as I said, SVG is now part of the spec. The big difference here is that this is an XML format, SVG. It is documented within the W3C, so it is a standard. S1000D SVG profile is an extension to the SVG 1.1 profile. So it's an extension of that. And one of the key things about SVG is there's no plugin required to view this data within a web environment or within an IATM. So it's supported by all the major browsers with no plugin required. So that's one of the attractive parts of it. So as I said, it's XML based. It's SVG 1.1 is what the S1000D profile is based on. There's also what they call a tiny profile, which really was designed for mobile phones. So the benefits are, as I mentioned earlier, is no plugin required for HTML5. It does support metadata, as CGM does, enabling interactivity. You can embed raster images, again, the same as CGM, so they retain themselves within the SVG file for editing. It also has the ability to include 2D animation, and it can be linked to spreadsheets as well, so you could have a data-driven graphic. So the main thing that actually changed with the profile, or the main part of the profile for SVG and S1000D, is the fact that it can contain hotspot information in a standard way. So if you go to the spec, you'll find in this 2.5 area that the actual profile code or attribute is data-APSID. So this is the name of the hotspot, the ID of the hotspot, and the name of the hotspot. So it's very, very similar to CGM. Actually, this part here, which is the part that would be in the XML, the S1000D entity, is exactly the same. So in theory, your authoring would remain the same when you insert hotspot information into a data module. The only thing that will change is when you export out as an SVG, then these attributes will be part of the SVG file, which they can be identified in the data module. So in practice, you can see here that data-ASPID, and then we have the associated ID, and then we have the associated name as well, which is here is just a standard layer, but this will be the name of your hotspot. The other mention of SVG within the spec is in the hotspots area, so you can go and look up that as well. It's quite a long chapter name, but these slides will be available for you tomorrow, so you can download them. So this slide has been updated now. We now can have an SVG as part of the spec. So we can have really 5 different parts to this. We can have the data module itself, which is essential, a CGM or an SVG graphic. And this would give us the ability to have interactivity between the XML or the CGM or the XML and the SVG. There's also an XML companion file, which I mentioned earlier. This works at the moment with the CGM illustration, but as part of this work we've been doing on this presentation, we've also think there's no reason why an XML companion file could not work with an SVG as well. It might just have to be slightly differently output, but it is something that we believe is possible. And that could be also the same as the kind of less used IMF. I'm not sure of any projects using this at the moment. So just in a bit more detail, we have the data module, the XML data module. The CGM or SVG data will be part of that or linked to that. The CGM and SVG would have the metadata for linking purposes. Doesn't have to, but it can. And then we have the companion file, the .xcf, which is part of the spec. I've not actually put a reference to that, but you can look it up. One thing here is that the viewer would have to support that companion file. So not all viewers do support the companion file, so that's worth noting. And then the IMF is the final part, which was introduced back in 4.2, which really gives an opportunity to add a lot more metadata to the ICN, to the illustration, to manage it. As I said, I'm not really aware of anybody using that at the moment. So just looking at the code, so the data module itself, from our what we've been looking at so far, is that the hotspot information within the XML file will not really change, because we can see that application structure ident is the same both for CGM and SVG. The only thing that would change, really, well, there's nothing really in here would change, but in the illustration itself, the CGM would have a different ID or way of naming the ID and name to SVG. So that's the difference. So you'd have to export them, either CGM and SVG, and they'd have slightly different information in containing them. So in the data module itself, what would change up at the top of it here in the header would be that instead of CGM, it would now be SVG, will be called out as a notated graphic. So this is the companion file. So you can see here that so this is the XML file. So you can see here the ID is the actual CGM ID. So we'd have to kind of append this with a data dash for the XML companion file to work. So we're going to look at that and probably we might propose something as a change request to the actual S1000D working groups or the committees. Or certainly one of our customers might do that. And then in the IMF file, then again, it's called out in a different way again. So that would have to be looked at separately. So as I said, I don't know really any projects using the IMF at the moment. We did write a article on that if you want to learn more about it. And it will be really up to vendors to actually support that format as well. So I'm just going to move on to the next demo. I'm going back to VisX Edit. Okay, but at first I just want to quickly show you some code here. So I've just opened this in Visual Code. So this data module here is actually from the new bicycle pack from issue 6. So you can download this and have a look at it. So you can see here that the SVG is notated. So this is actual live data from their demo data from the S1000D committee. So you can see this is the data module now with an S1000D data module containing an SVG file. And here we can see that the actual callouts, the structure to call out and link to those hotspots within the SVG file. So you can see that this would really look exactly like if it was calling to a CGM file. The only difference would be is the linking between the two. And this is the ICN, the SVG, as part of that spec as well. So within here, you can see this is the bike. You can see the hotspots on here. So you can download this information from s1000d.org. So you might find that useful just to learn a bit more about it. Yeah, so just going back to here, let me just reopen this file. Okay, so this is a CGM with hotspots. Oh, sorry, this is just an illustration with hotspots. We can highlight those within VisX Edit just to see where they are. And if I click on one here, so this is number 1, and then modify, we can see the ID and the name of that hotspot. So when we export out of here with this as a CGM, then it would have that particular property, the app's ID property and the app's name. But alternatively, now we have that ability to save, and we can save it as an SVG with the S1006 profile. So we've just literally added this in the last few weeks. So you can now save, in theory, compliant SVG files, S1000D SVG files from VisX Edit. You still have the ability, we've left in here our previous one I spoke about at the beginning, Tech SVG, but we now obviously see people will now move over to the official one. Okay, so these hotspots, so how are they going to work in the viewer? So let's just go over to here. So here we, that's the illustration I showed. You can see that it's got these actual tooltips on here. But I did mention I'll try and show you the XML file. So if we had multiple tooltips, we only have the option within the CGM to add one, or the SVG for that matter. You can only really add one. But here we can have multiple within the XML companion file. So we could change on the fly to a different language, for instance, for the tooltip. So it's the same illustration referencing the XML companion file. So our viewer is capable of actually presenting this. So not all viewers support the XML companion file. And then we can also have interactivity. This is a CGM file, so we can have interactivity between the hotspot and the table here. So this is PhysXView HTML5, which is Don mentioned for viewing CGM files without a plugin. So we have customers who are still using CGM who use this particular technology. And then we created a new example, this time using SVG. And this is our PhysXView SVG technology that allows us kind of off the shelf to actually have a toolbar and so forth, and to view the SVG and the XML. So now we're doing a similar thing, but we're using that S1000D bike example. So you can see as I move over the hotspot, it highlights the table, and also in reverse. So it works both ways. But now we have a standard way of doing that within the specification. Okay, so let's just go back to the slides. So I'm going to move on to 3D. So these guidelines haven't really changed in issue 6. I think it's going to be issue 7 before we see some new guidelines or some updated ones. So some of the guidelines, again, are pretty much common sense. You know, you want to gather your engineering data, you know, from a reliable source. Because what we're going to do is actually there's two things we could do. We could actually, step 1, we could actually create 2D from the 3D. Or in step 2, we could create a 3D illustration from the 3D. And we'll look at both of those today. So S1000D doesn't currently recommend a 3D file format, but the specification does state that you should document those. Any solution you do choose or select should be documented in the project business rules. It does kind of leave it open to use in any file format, but we would always recommend, our guidance is really to use an open 3D file format for display and for exchange, and for exchange for that matter. But certainly for the display, it's important they use an open one, not a proprietary format. So 3D to 2D. To do that, you're really going to have to get CAD data and manipulate that model in some way to actually create your 2D data. STEP is a format we support, and it's actually referenced in the S1000D specification as for CAD data exchange. So I'm not really sure which chapter it is in, but it is a reference standard in S1000D. So some of the considerations, if you're going to start working with that information from an illustration point of view, is that the file sizes can be really large, and they're definitely not suitable for publishing in an IETM. So you're going to have to find another file format to publish that data for your end user. So quickly on to another demo here. So this time I'm going to This is VisX Edit 3D, so I can import in here, just find a file. I want it to be step. We mentioned step a few minutes ago. So I'm going to open this step file. Quite a small file just for demonstration purposes. And what I can do here is quickly just, I can explode this file out. Oh, sorry, let's just create a new explosion. Oops, so I'm just going to just drag this away. And then I can select some of the items here. So this is the 3D step model I'm working with. So I'm just going to explode this out, not too far. Okay, and I'm going to save that. Let's just go back to manage. So I've just created that view. So that's the view I just created. And I'm going to export this out. Now I've got CGM here. We've also have the option to go to SVG, so you could go to both formats really quickly and be standard on those files. So this is going to let's do a hidden line removal and create a 2D file. So let's just, I'm just going to do this. All those settings look good. Okay, so I've created this 2D file. So these are all vectors now. And what I could do is start annotating this and adding hotspots to this particular illustration. So very quickly from 3D, I've gone to 2D, and I've got a nice kind of line art illustration, which you could use. Okay, so let's go back to, and this time we're going to go 3D to 3D. Sounds a bit strange way of putting it, but we're going to retain that 3D property to the file. So there are some guidelines around how we would do this of 3D content and its usage. Some of it's quite detailed and probably too high level, but it's basically saying you really need to still have warnings and cautions. You know, you need to put things into business rules to document what you're going to do and what tools you're going to use. Things like text and so forth, if you annotate, really should not be 3D. They should be what we call billboarded, so they don't kind of rotate with a model, so they're always legible. And also they should be, you know, color coordinated to warnings and cautions and so forth. And if they're animated, then they should be done as they in a way that doesn't put their maintainer in a hazardous position and things like that by still displaying warnings and cautions. Color, I think this is kind of not that feasible. We still use the color palette of S1000D because when we get models through, there could be all sorts of colors. So, but certainly if you're going to use warnings and cautions, still warnings should be red, cautions should be amber, things like that. So you should still kind of make those standard colors. But the model itself, that's going to be almost impossible to maintain the color palette for that. And this is one of the reasons these guidelines are probably going to be revised. Again, camera positions, different views of the model. I personally see these being pretty much fixed for the user to a certain extent. In other words, they won't have free rein to move around the model as they wish, because that could be not very helpful in some ways, could get the wrong idea. And isometric is still probably a good projection to use to show the model in the best light. So although the spec hasn't selected a format for display of this in an ITM, we decided to do that of our own volition, and that's really because we had customers who wanted to use 3D data within their IATM. So we obviously selected an open format because that's our own guidance, and we selected a format called GLTF, which is managed by the Cronus Group. You can see the web link there at the top. The big benefit of GLTF is there's no plugin required to view this 3D data in a web browser. It's very efficient format, small. It really optimizes the file size of the 3D model. And it's also got good support from large software companies such as Microsoft and Adobe. So those are some of the factors we did that made our selection a lot easier. And also that just generally it seemed to do everything we wanted to do from a technical publications perspective. So this is the final demo. I'm going to go back to VisX Edit 3D for this, but I'm also going to show you how we would display these images as well in VisX View 3D. So I'm just going to go back to this model, but this time I'm going to animate it. So before I was just exploding it as an explosion, traditional kind of exploded illustration you have in 2D. This time, instead of we can still explode it, but this time we'll animate that at the same time. So you can see at the bottom here we have a timeline. So if it's now click on the part and I move it away from here, we can add it to the timeline. So we can apply that. So now this part is moving away from here. So I can just play that back. And then as before, I can now select multiple parts. So all these bolts that are going in here, I can select them all at the same time and just move those away and apply that. So very straightforward to start animating this. If I want to go back and add something more to this, so in other words, if I want to make these fade away to create some more room, I could just fade those and apply it. So now if I just go back and play this back, and those parts will fade away. Okay, so this is where I would save this as a GLTF or a GLB file. So export this out. So I said this is not a standard within the specification at the moment, but I can choose this and export this out as a 3D file. So from the step file again, I've created a lighter file format that enables me to put it into an IATM. Okay, so what does that look like? So let's go back to, in this case, it's Chrome. And now we're in, this is VisX View 3D. So this is our viewer. So what we've done here is you'll still get tooltips and so forth, but now we have the step related to that step of the animation enabled. So when I move that part away, we can play it back, what we just created in the animation. So step 2, step 3, oh, sorry, it should fade away. Then we remove the gear, and then it's going to change. So we could change the camera position as well. Remove the gearbox. And then we'll just go through, and that removing a compound angle, and then we can have a warning or a caution associated with that as well. Okay, so let's just go back to the slides. Yeah, so that was VisX Edit 3D and VisX View 3D. As I said, we selected that format. It's not part of the spec currently. So just in summary, our primary focus at Larson was always really to be developing products that are compliant with the S1000D spec. So, and now we include SVG, the new SVG profile. So that's part of VisX Edit, part of VisX Edit 3D. We saw today VisX View HTML5 SDK, which is for viewing ZGM graphics, which again, compliant with the spec. And also a fairly new product is VisX View SVG, which again is compliant with the new profile of the spec for viewing your SVG files. And then the VisX View 3D SDK for viewing 3D files in a web environment or in your IATM. So we're going to continue to contribute to the spec, part of the working group. And next year we'll have the user forum in Canada, in North America, and we will participate in that. So we'd be really happy to see you there if you can attend. So at this point, I'm going to just go over to the Q&A. And Don, if you can rejoin me at this point, perhaps.
Yes, I'm here.
Okay. Okay, somebody just saying that you can hear me, so which is good news, to be honest, because you might have heard my phone ring, and I thought my microphone kind of switched over to the phone, so that was just one of those technical difficulties when you're going live. Okay. So I've just got a question here. CGM companion file is IMF S1000D type. So the XML companion file is a .xcf file. The IMF file is fairly new to the spec. And as I think I mentioned earlier on, it could serve as a companion file, if that was the question, the IMF file. But it's, to my knowledge, it's not being used as that at the moment, unless there's a project who wants to kind of come forward and say they are, but I don't know of anybody using it. But certainly the XML companion file is being used by projects, I think mainly in commercial aerospace. Don, have you any knowledge of that, where XML companion files are being used?
I think commercial,
Yeah, I think so.
I mean, I think the advantage of the XCF is you can put put content in, text, screen tips in there, which I don't think you can do with the IMF. So
yeah, that's a good point. Is it possible with? Yeah, somebody said if our CGM to vector, we haven't really spoke about that today. Our conversion technology, CGM to vector, which supports SVG as well as EPS. Yeah, that does now support the S1000D SVG profile. So yes, it does. So we've now released that, haven't we, done? CGM to vector.
Yes, that is correct. We have.
So if your customer, we've only just done it. So if you're a customer who wants that, just drop us an email to support@cgemlarson.com, and we'll give you a link to the new version. So this is a question around CGM to vector, Don, the conversion tool. Are we still supporting the Tech SVG in there?
Yeah. Yes, we do. You can select your both in the editor and in the conversion tool to convert to the new or the old. No, but I think his question also asks, can we convert from the old SV profile to the new in the converter?
Oh, sorry. Yeah.
And that is not possible there because CGM to vector only reads the reads CGM. I could add here though that we have another tool that's more flexible, has more to it. It's called VisX Transform, and that would allow you to read the old format and convert to the new, but not in the converter.
If you still had the original CGM files, you could still do it though.
Yes, that is correct.
Yeah, yeah.
Right.
So if you had the original still, if you're still creating CGMs and then converting to SVG, you could select the latest profile. So that's
Yes.
possible.
Yes. Right.
Can we demonstrate the auto call out tool? I'm afraid we won't be able to do it now as part of this webinar, but we can definitely do that off. If you want to set up something with us offline, we can show you the call out tool. So as part of VisX Edit 2D, if you want to call it that, we have a call out tool that will automatically create numbers, but also hotspot that as well at the same time. So there was an example illustration with the call outs on. So they were all done with the call out tool. But yeah, we'd be happy to do that if you contact us, and we can set something up to do that with you. Okay, so I've got a lot more questions coming in. Stat file was mentioned, but is there any other 3D format that you would allow sharing 3D data with? I'm not sure if I quite follow that. So the step file is not something that would be something usually sourced from the engineering area, but it's not something you would deliver as part of the IETM. So that's why we have the GLTF format. And it does obviously simplify the geometry because it's an optimized file. It's for visualization. We also support IGES as well as STEP for import of data from CAD systems. We don't really support any native file formats. Do you want to quickly look at that question, Don? Am I answering that correctly?
Yeah, I think you covered. I think, yeah, STEP is primarily a way to exchange the complete model, with geometry and all, and so it wouldn't be recommended for sharing, for just sharing the 3D assets, for viewing purposes. So the GLTF would be the format to use for the sharing the asset.
Okay.
Yeah, I think that answers it. But if that attendee wants to ask in more detail, please post, and we'll deal.
Yeah, please email support@clarson.com.
Yeah, or just online if there's if they want to hear, we can address it if we haven't done so.
Yeah, the next one is on STEP as well. Have we ever encountered files that don't open? STEP files that don't. We have encountered files that cause issues, and probably some STEP files aren't actually exported correctly, or the model has not been created correctly, or the file size is very large, and your computer might not be capable of opening them. We are doing a lot of work and have done a lot of work on optimizing the import of STEP files. And also there's certain settings that you should apply as well, not particularly on opening them, but certainly processing them to 2D. But if you have an issue, if you're a customer with an issue opening a file, you don't have to share that file with us. We can just go through some things with you that might help. But certainly not every file, will open, but the majority will, but it's usually down to file size sometimes that you might have an issue with your computer, perhaps having the actual RAM available to open it. Okay. Got a lot of questions to go here. Can you help clarify illustration rules? How exactly is the centerline method intended to be used? Yeah, the centerline is usually used in a spare parts type illustration to indicate where that part came from. So that's the usual use of it, and it's usually a chain dot line as a rule. That's the usual kind of style of it. But it is usually used as a way of showing a location, a center line of where the part actually came from. I don't believe this is supported. Perhaps, Don, you want to take that on SVGZ?
Yeah, the question is SVG, zip compressed SVG supported by the S1000D profile? Like binary CGM is to reduce the size. It's not explicitly addressed in there, but I can't see a reason why that would not be a good practice. SVGs can get quite large, and so compressing them would be a good thing to do to reduce storage space. So that's probably something we ought to need to address. That graphics and multimedia working group, it should be kind of maybe mentioned as that is a could be part of the standard, but I don't think it is mentioned.
Would it affect, Don, a question from me, would it, saving as that file format, the metadata would still remain the same within it, would it?
Yes, yeah, everything is retained. It's just scrunched down. It's compressed.
And it have a different kind of, it wouldn't be SVG, dot SVG with dot SVGZ, is that right?
Yes, correct.
Okay. Okay. Okay, I think that's it. Is it? Yeah, I think so. Okay. Yeah. So thanks everybody. So hopefully everything came through. You could hear me. I got some things in the questions that you could still hear me, so that's good. Thank you, Don, for your help there with the questions, and thank you for all the questions. That's really, really good of you to put those forward. Hopefully we've answered them. If not, you can email me or support@cgmlarson.com, and we'll try and help you out further. But otherwise, yeah, thanks for attending today. I think this will be our last webinar of 2024. So if we don't speak to you in the meantime, please have a great holiday break, and we'll probably speak to you again in the new year. So thanks again for attending today, and we'll speak to you soon. Thank you.